Hey, what's up, guys? Day 23 coming at you right after we finish test number 2. Good work in prepping for that test. A lot of rules to remember, a lot of stuff to have memorized. But it's going to be important. We're going to need all that stuff memorized when we take the AP Calc test. We're also going to need it memorized for what we're doing in our next standard, which is implicit differentiation. Implicit differentiation sounds really difficult, but it's not. Differentiation just means derivative. We do implicit differentiation whenever we don't have y explicitly defined. So let me give you an example of explicit versus implicit. Explicit means that we have an equation where y is explicitly solved for. So here are some examples of explicit, what we're used to. Notice in all of these equations, there's only a single y. It is to the first power, and it has a coefficient of 1. That means y is explicitly defined. It says y equals. Explicit just means y equals form. And everything on the right side is in terms of x. Implicit means that there can be x's and y's, but there might be multiple y's, and y is not going to be by itself. Notice in our implicit form, it is not specifically in y equals form. So some of these we can put in y equals form, some of them we can't. The other thing about implicit functions, that's a bad word to use, implicit curves, is they're not always functions, right? Take a look at that first one, x squared plus y squared equals 25. Well, that's the equation of a circle centered at 0, 0, with a radius of 5. That is not a function, right? That's a relation because x values can give us 2 different y values. So oftentimes these are referred to as curves, not functions, just because oftentimes they aren't functions. The question is, how do we find the derivative when we have something that's implicitly defined? How do we find dy dx when y is not explicitly defined? Right? We could do the derivative of all those ones on the left side, but how do we do the derivatives of the ones on the right side? So here's what we need to know. Differentiation. First thing we need to know is that all rules apply. So the different rules that we learned, product rule, quotient rule, chain rule, they still apply. When we see a function times a function, we still have to execute the product rule. When we see a function divided by a function, we still have to execute the quotient rule. When we see a function within a function, we still have to use the chain rule, right? And we can use multiple rules on one problem. So all rules apply. The second thing to remember is, we're going to come across both x's and y's. So we do the x's as normal. So derive the x's normally. So whenever we come across an x in our derivative, for example, looking back at our implicit functions here, if we were doing the derivative of this function right here, when we come to the derivative of x squared, we're going to say 2x, because we know that's the derivative of x squared. So we do the derivative of x's normally. When we come across the y's, we want to also derive the y's normally. But then we tack on dy dx. By tack on, I mean multiply by dy dx. So when I do if I want to do the derivative of y squared, that would be 2y, but I have to multiply on dy dx. Think of it like the chain rule where we chain something on. We're chaining in the derivative of y with respect to x. The last thing we want to do is get dy dx alone. Sometimes there are multiple dy dx's in the problem, and that's okay. We get them together, we factor it out, and we get it alone. So our goal is always at the end, we want to get dy dx alone. And that's just algebra, it's not calculus. So those are our rules. Make sure you have those rules written down in your notebook. Maybe put a box in them. I see a lot of you guys highlighting your notes. That would be a good thing to have highlighted. And this will make more sense as we do some practice problems. Okay? So those are our 4 rules. Let's take a look at our first problem. So our first problem is that circle equation for x squared plus y squared equals 25. So we want to find dy dx. Now, sometimes people want to explicitly define y and then go from there. Well, if you think about doing that, if we explicitly defined y, we would have to subtract x squared, and then we'd have to do the square root. But that would have to be the plus or minus square root of 25 minus x squared. That would not, that would be 2 different functions we'd have to use to make a circle. So that's not going to be very helpful for us. We'd have to do 2 separate derivatives, and it would just get really messy. Doing this with implicit differentiation is going to be much easier. So here's what we want to do. We want to go through this thing and do the derivative of everything in this equation. We're going to remember all of our rules. We're going to do the x's normally, and when we do a derivative of y, we're going to tack on dy dx. Then we're going to get dy dx alone. So let's go through and just start doing the derivative. So I want to start with the derivative of x squared. I think about rule 2 here that says do the x's normally. So the derivative of x squared is simply 2x. Because I'm adding x squared and y squared, I don't have to worry about a product rule or a quotient rule or a chain rule. I just need to add in the derivative of y squared. Well, again, think about rule 3. Rule 3 says do the y's normally, but tack on dy dx. So the derivative of y squared is 2y. But I have to tack on dy dx, so it looks like this. Lastly, I have to do the derivative of 25. Well, what happens when we take the derivative of a constant? Well, the derivative of 25, it's just a number. The derivative of a number is always 0. So we've completed steps 1 through 3. We remembered to use all of our rules. We did the derivatives of x's normally. We did the derivative of y. When we did that, we tacked on dy dx. And the derivative of 25 was 0. Now all we have to do is get dy dx alone. Well, the first step to getting dy dx alone would be I'd want to subtract 2x from both sides. Zero minus 2x is obviously negative 2x. The last thing I want to do to get dy dx alone is to divide by 2y. And divide both sides by 2y. And when I do that, I get dy dx equals negative 2x over 2y. One more thing I want to add to number 4. Get dy dx alone and then simplify. The simplifying can be tricky on this, but this often shows up on the multiple choice section, so they're only going to report simplified answers. So I really want us practicing our simplification here. What do we see that can simplify in this problem? Well, we can see that we can divide both the top and the bottom by 2. When we do that, we get a final answer of negative x over 1. And that is our first implicit derivative. The next function I want to take a look at is this one. Go ahead and copy that curve into your notes. I don't really know what this looks like. All right, we can go on Desmos. I might show you in our next video what some of these curves look like. You can go on Desmos and figure out what it looks like. Oftentimes they're kind of cool looking. But what I want to do here is I want to just simply find dy dx. Just like the last problem, this one doesn't have any product rule or quotient rule or chain rule in it. But what is different here is notice that y shows up in 2 different places here. Right? I have the 3y term right here, and I have a y squared term. Well, every time I do a derivative of y, I have to tack on dy dx. So I'm going to end up with 2 dy dx's in this one when I go through and derive all the terms. And that's okay. We can fix that. We can get dy dx alone. I'll show you how it works. So let's go ahead and start doing the derivative of each piece of this equation and see what happens. So let's start with the derivative of x cubed. That's going to be very simple. It's going to be 3x squared. What about the derivative of 3y? Well, we're going to do that derivative normally. The derivative of 3y would be 3. I just have to tack on a dy dx. So this is going to say plus 3 dy dx. Notice I no longer have a y term in there. All right, just like the derivative of 5x is 5, the derivative of 3y is 3. I just have to multiply by dy dx. Plus, what's the derivative of y squared, you ask? Well, simple, 2y. dy dx. I got to tack on that dy dx every time I do a derivative of y. And what's the derivative of 17? Well, that's simple. It's just a constant. Its derivative is 0. Okay. So after going through and doing all the derivatives, I'm left with this equation. 3x squared plus 3 dy dx plus 2y dy dx equals 0. Now I want to get dy dx alone. Well, the nice thing is the bad thing is I have two dy dx's. The nice thing is they're already on the same side of the equal sign. So I want to get everything that's not attached to a dy dx to the other side of the equal sign. I'm going to do that by subtracting 3x squared from both sides. Now, how do I get dy dx alone? Well, if we notice, dy dx shows up in both of the terms on the left side of the equal sign. Well, I'm simply going to factor out a dy dx. So all I did is, right, I could have 3, 4, 10, 15 dy dx's. All I got to do is factor it out. My last step to get dy dx alone is I want to divide both sides of the equation by 3 plus 2y. And I get my nice final answer of negative 3x squared over 3 plus 2y. Now, after we get dy dx alone, we want to look to see, can this be simplified? Now, you may be tempted to divide out those 3's, but notice not every term has a 3 in it. Not every term has an x in it. Not every term has a y in it. There's nothing else we can do other than leave it as negative 3x squared over 3 plus 2y. Okay. Let's try another one. With this curve now, I see the function 5y plus 3xy equals 16x. Once again, I see multiple y's, but we know that doesn't bother us. What's going to be different about this one is notice that I have 3x times y. 3x times y, that is a product of two different functions. Right? This right here is a product of two functions. To do the derivative of 3xy, I must use the product rule. What I want you to do when you do this is I want you to identify your two functions. One of my functions is going to be a positive 3x. The other function is y. I really want you to consider that sign, that plus in front. If you forgot about it on this one, it wouldn't be a big deal. But it is a big deal if that's a minus. We'll take a look at that in our next example here. Okay, so let's just go ahead and try this thing. The first part is easy. What's the derivative of 5y? Well, that is simply 5 dy dx. Now is when it gets interesting. right? Don't forget to tack on your dy dx there, right? Then for the next part, I need to do the product rule. The product rule says the derivative of the first times the second plus the first times the derivative of the second. Now, anytime I do a derivative, if I'm doing the derivative of x, I just do it normally. But when I do the derivative of y, I have to tack on dy dx. So let's start. The derivative of the first is the derivative of positive 3x. Well, that is positive 3. That's the derivative of the first. But the product rule says I do the derivative of the first times the second. Ask yourself, do I need a dy dx there? Oh, which one did you do the derivative of? You did the derivative of 3x. That does not require tacking on a dy dx. Next, I want to, product rule is plus, so I want to add on the first function, which is a positive 3x, times the derivative of the second. Well, the derivative of y is 1, but I need to tack on to 1. I need to do 1 times dy dx. I chose not to put that 1 in there, so it doesn't get confusing. So right here I have the derivative of the first, 3, times the second, y, plus the first, 3x, times the derivative of the second, dy dx. And I'm almost done. I just have to derive the right side of the equal sign. The derivative of 16x, it's an x, so I just do it normally. The derivative of 16x is 16. So that's what it should look like after you go through and do the implicit differentiation. The last thing I need to do is I need to get dy dx alone and simplify if possible. So if I notice here, I have 3 terms on the left side. I have 5 dy dx, I have a 3y, and I have a 3x dy dx. I want to keep the dy dx's together on the left side and get anything out of there that doesn't have a dy dx in it. So I'm going to subtract that 3y. So I subtracted 3y from both sides. Goes away on the left side, and we get 16 minus 3y on the right side. Now I want to factor out my dy dx. And lastly, I want to divide both sides by 5 plus 3x. Now I want to ask myself, is there any way I can simplify this? Well, I look for x's, I look for coefficients, I look for y's. There's not a single number that divides all of these. They don't all have the same variable throughout. Therefore, I can leave my answer as 16 minus 3y over 5 plus 3x. Good, let's take a look at another one. So here I have 4x squared minus 10x cubed y squared equals 6. Taking a look at this, what rule do you think will come into play here? Did you say product rule? I hope so, because that's the rule we need. Let's go ahead and do this one. Or actually, if you want to, pause the video, see if you can get it, then unpause it and see the answer. There's one thing in here that's going to be a little bit tricky. It has to do with that minus. Okay, we're back. here's what we get. I'm going to have to do a product rule here because I have negative 10x cubed and y squared. I like to really emphasize the fact of that minus sign there. Okay? I'm thinking of my first function as negative 10x cubed, not of just regular 10x cubed. You can think of it just as 10x cubed, but then that minus sign, you need a parenthesis around your whole product rule, and you need to distribute that negative in. I think it's easier to consider the negative with the 10x cubed. Okay, going ahead and doing this, the derivative of 4x squared is simply 8x. That's easy. Now I have to do the derivative of the first times the second plus the first times the derivative of the second. Well, the derivative of the first will be negative 30x squared. That's the derivative of the first times the second. No dy dx needed here because the derivative was of the variable x. Product rule says plus. Here's where people screw up. Tons and tons of people get this answer wrong because of this. We know the product rule is plus, but now I need to multiply the first by the derivative of the second. The first is negative 10x cubed. So we're doing plus a negative 10x cubed. Tons and tons and tons of students who do this problem simply write plus 10x cubed. They don't see that that's actually going to turn into subtraction there. So we did the derivative of the first times the second. Now we have to do plus the first, negative 10x cubed, times the derivative of the second. The derivative of y squared would be 2y, and I need to tack on now dy dx. So I executed the entire product rule. So I'm left now to do the derivative of 6. The derivative of 6 is 0. Clearing this up, I would just write 8x minus 30x squared y squared. This simply becomes minus. Notice I have a coefficient of 10 and 2. I'm going to multiply those together and call it minus 20x cubed y dy dx equals 0. Oftentimes when we do the product rule with these, before we start getting dy dx alone, it helps to simplify a little bit. Now I want to get dy dx alone. Notice that the 8x and the minus 30x squared y squared don't have a dy dx in them, so I'm going to move them to the other side. I'm going to subtract 8x, and I'm going to add 30x squared y squared. So I'm left with this. That's not the only way you could have done that. It might have actually been easier to just add the 20x cubed y dy dx to the right side. That would get it alone. Either way would work, right? We just got to be very careful with our signs on this. Okay? Next thing I want to do is to get dy dx alone, I want to divide by negative 20x cubed y. And I get dy dx equals negative 8x plus 30x squared y squared over negative 20x cubed y. This is the right answer for dy dx. It's just not very simplified. So what I want to do now is divide all those numbers, right, and simplify this thing. Well, 8, 30, and 20, well, I know they all divide by 2. And I think that's the biggest number, right? Because 4 wouldn't divide 30. So, and I'm actually going to divide by a negative 2 here. I'm also going to divide everything by x, because notice every term has an x, but not every term has a y. So I'm going to divide everything by negative 2x. Oops. I got to do this quickly because another class is coming in. We get dy dx equals 4 minus 15xy squared over 10x squared y. And I was doing that kind of quickly. Hopefully that's the right answer. That's it for today. We'll practice these tomorrow in class. Have a good one. Bye. Sorry for the long video. It's worth it. Bye.